I'm Anil Kumar. Welcome to my series on functions. In this video, we'll discuss a complete test paper on rate of change, which is Unit 2 for pre-calculus curriculum on functions. There are 16 questions in this test paper. Let's begin with the very first one. Question 1. Slope of which type of line represents the average rate of change of a function over an interval? 4 choices are given to you. You can mark the right choice. Question number 2. Which function has a negative rate of change on the interval 1 to 4 out of these? And question number 3 here is, consider the function f of x equals to minus x squared plus 2x minus 1 for which value of x is the instantaneous rate of change negative. So these are the 3 multiple choice questions. You can pause and answer them and then look into my suggestions. Now, as far as the average rate of change is concerned, it is always given by the slope of the secant line, correct? Question number 2. Which function has negative rate of change out of these, right? So now this is the constant function negative 5. Some students mark that as the answer. Here, the rate of change is 0, right? It is a constant function. This is a straight line. Rate of change is plus 3, so it's not negative. We are also looking for interval from 1 to 4, right? So from interval from 1 to, which function has a negative rate of change? Now, this function, minus x squared, will be a parabola which is going to go down kind of like this. Do you see that? And this point vertex will be at x equals to 0, right? So this is at x equals to 0. So if we are on the right side, we do have a negative slope, and therefore this function will have a negative rate of change on the given interval. So you don't really have to do any calculations here. Use this kind of a strategy to get your answer. Question number 3. Consider this function for which value of x is the instantaneous rate of change negative. It's very similar to the previous one. Now let's figure this out. We are now given some points, not an interval. So this function minus x squared plus 2x minus 1, let's rewrite this as minus outside. We have x squared minus 2x plus 1. Now that can be factored, and we could write this as x minus 1 whole square. So x minus 1 whole square will be a parabola which will be again going downwards, and this vertex here this time will be at x equals to 1, and negative will be on the right side of 1. The only point given on the right side of 1 is 2. So that is going to be the point of our interest. Is that clear to you? So that is how we are going to solve these 3 questions. Now let's move on and take the others. Question number 4 is kind of a concept-based question. It's also a communication question. Let's try to understand the concept. Question 4a. On a displacement versus time graph, what indicates that there is no change in displacement as the time increases? Question 4b. On a speed versus time graph, what indicates that there is no change in displacement as time increases? Question 4c. The instantaneous rate of change of h of x is the same for every real value of x. What can you conclude about h of x? And 4d is, provide example of a function for which the instantaneous rate of change can be any value. So let's begin with the very first one, which is based on displacement versus time graph, right? So we're talking about displacement versus time graph, correct? Now, on a displacement versus time graph, what indicates that there is no change in displacement? Well, if I have displacement, it will always be on the y-axis and time on the x-axis. Then what indicates that there is no change in displacement? That means we should have a horizontal line, correct? So this indicates that there is no change in displacement. It is constant. Do you see that? So a horizontal line shown here. So a horizontal line. No change, right? It's like a stand still, right? So standing at a point, right? No change. Now part B is on a speed versus time graph. So this time we'll now look into velocity or speed versus time graph. So let's have speed S, right? And time t here. On a speed versus time graph, what indicates that there is no change in displacement? Now here, area under the curve is distance, right? I should say distance, correct? Anyway, we're talking about displacement, and therefore that should be a horizontal line along speed equals to 0, right? That is kind of important. Stand still, right? That means no motion, no movement. So speed equals to 0. So speed equals to 0 indicates that there is no change in displacement, right? Is that clear to you? So if there is no speed, the body is not moving at all. That means it is standstill, and therefore that will be indicated by a horizontal line along the time axis. Perfect. 4C. The instantaneous rate of change of h of x is the same for every real value of x. What can you conclude about h of x? Now, if instantaneous rate of change is same, constant, that means what do we have? We have a linear function. Correct? So you have y equals to mx plus b, correct? You know m is slope, which is constant. Do you see that? Right? And therefore, that is what is kind of a reminder, right? So for this, we are sure that it's a linear function. It could be any linear function, a line which is kind of like this or whatever. Perfect? But basically, linear function. Is it clear to you? Question 4D now. Provide example of a function for which the instantaneous rate of change can be any value. Well, there could be many functions, but the best will be, we can say that the function is x function. So if you take a parabola, as you can see, you could take a parabola. So in a parabola, you will notice that the slope changes from negative value to 0 to positive value, right? So there are no restrictions. On the left side of the vertex, we have negative, and then we have 0, and then positive, correct? So we need to provide example for which the instantaneous rate of change can be of any value. So the function is x squared, correct? So that is a common function where there is no restriction on the value of instantaneous rate of change, right? Question number 5. A speed versus time graph shows the segment from 3,4 to 8,4. The units for the vertical axis are meters per second. If the object whose speed was being graphed is 12 meters away from the point from which the measurements are made at t equals to 3, how far is the object at t equals to 8 seconds? Right? So let's try to understand this situation. So what we have here is we are saying the speed versus time graph, that means speed versus time graph, shows a segment from 3,4 to 8,4. Let's say this is from, this point is 3, right? So that is 4. To this point is 8. So these are the 2 points we are trying to show. So this is a horizontal line, right? So a speed versus time graph shows the segment from 3,4 to 8,4. the units for the vertical axis is meters per second. This is meters per second. If the object whose speed was being graphed is 12 meters away, so what we know from here that the speed is constant and it is 4 meters per second, right? Now we are saying if the object whose speed was being graphed is 12 meters away, so that means if we talk about position or distance, let's say distance and time, then at 3 the object is 12 meters away, right? Perfect. So after 8 seconds, how far will the object be? Right. So so if the object whose speed was being graphed is 12 meters away from the point from which the measurements are made at t equals to 3, so at t equals to 3, it is 12 meters away. How far is the object at t equals to 8? So how far is it at t equals to 8? That is what we need to figure out. Since the object is moving at a constant speed, it will move like this. Is it okay? So that is the distance which we need to find. Correct? So a couple of ways we can do it. We know that the initial distance d0 is given to us as 12 meters, right? Now the object is moving with the speed or velocity of 4 meters per second, right? And it travels for time which is 8 minus 3, which is 5 seconds. So additional distance or change in distance will be velocity times time or speed into time. So it will be 4 meters per second times 5 seconds, which is 20 meters, right? So the final distance will be 12 plus 20 or 32 meters. Is that clear to you? So how far is the object at t equals to 8 seconds? It is 30 meters away. So that is our answer. Is that clear to you, right? So the 32 meters away. So the object will be 32 meters away at t equals to 8 seconds. Perfect. So that is how we are going to answer this question. So I hope it is absolutely clear. Now let's take up the next question, which is question number 6. The table below shows the number of copies of a new video game sold by an electronics store each week for the first month after the game's release. Week number 1, 2, 3, 4, number of copies sold is 135, 100, 58 and 39. What is the average rate of change in the number of copies of the game sold from week 1 to week 4? So average rate of change will be number of copies from week 1 to week 4, right? So we're looking into these two. Perfect. So we'll do copies sold in week 4, which is 39, minus 135 divided by 4 minus 1, correct? 4 minus 1. So that is what we'll get. Let's use calculator. So we have 39 minus 135, which is minus 96 divided by 3, or it is minus 32, right? So average rate of change is number of copies per week, right? So many copies per week. Is it clear to you? That is what we get as solution to part A. B. Describe this average rate of change for the real life situation, right? So how will you describe this? Well, that really means that every week 32 less copies are sold, right? So that means every week clear? That's what it means. Perfect. Question number 7. Estimate the instantaneous rate of change in P of t equals to 25 times 1.08 to the power of t at t equals to 3 to 2 decimal places. So when it is 2 decimal places, then we are going to take time, t in this case, from 3.001 to 3, right? So that will give us 2 decimal places. So let's find the instantaneous rate of change. So instantaneous rate of change in this interval for the given function will be 25 1.08 to the power of 3.001 minus 25 times 1.08 to the power of 3 divided by 3.001 minus 3, correct? So we can take 25 common, so we get 25 over 0.001, and here we get 1.08 to the power of 3.001 minus 1.08 to the power of 3. Let's use calculator now. So we have 1.08 to the power of 3.001 minus 1.08 to the power of 3 times 25 divided by 0.001. That gives us 2.4238, right? So rounding to 2 decimal places, we get our answer as 2.42, correct? So that becomes the solution. Next question here is, draw a distance versus time graph that corresponds to the walk below. Anil starts 5 meters away from the motion sensor and walks in a straight line towards the sensor at a constant rate of 0.5 meters per second for 3 seconds. He immediately starts walking away from the sensor at a constant rate of 0.25 meters per second for 4 seconds. He stops for a second and then walks towards the sensor at a constant rate of 0.5 meters per second for 2 seconds. So we need to sketch the graph here. So let me just create one. Right, so we'll make a small one here. Okay. So let me just draw some lines. So we'll make a rough sketch. However, you'll get an idea of how to do such questions, right? So we have 1, 2, 3, 4, 5, 6. And horizontally we'll have 1, 2, 3. Okay, so we are talking about distance with time. So Anil starts 9 meters away from the motion sensor and walks in a straight line towards the sensor, right? So 5 meters away, 1, 2, 3, 4, 5. So that is 5 meters. Okay, so that is the starting point. And it is given to us here that he walks at a constant rate. So the speed is 0.5 and time is 3 seconds, right? So therefore, distance will be 0.5 times 3. So this distance is going to be 1.5. Now, since he is walking towards the sensor, it is decreasing, right? So as far as distance is concerned, he starts from 5 meters and walks within 3 seconds. That means 1, 2, 3, 1.5 seconds. So the position after 3 seconds will be starting point 5 minus 1.5, correct? So 4 minus 1 is 3.5, correct? So that much away. So from here, after 3 seconds, 1, 2, 3.5. So that becomes the distance or the position after 3 seconds, correct? He immediately starts walking away from the sensor at a rate of 0.25. Now the speed is 0.25 for 4 seconds, right? So, and time is 4 seconds, right? Now when you multiply, the distance covered during this time will be 0.25 is 1/4 times 4 is 1 unit. So now 1 unit in 4 seconds. So from 3, 4, 5, 6, 7, he covers 1 unit, right? So after 7 seconds he covers 1 unit. So now the distance after 4 seconds, earlier 3 seconds, we'll add 1 to 3.5, so we get 4.5. So that becomes the position. That is what. He stops for a second, then he stops for 1 second. So again D8 is same as 4.5. And then walks towards the sensor, means away, at a constant rate of 0.5. Okay, let's see. He stops for a second and then walks towards the sensor. So when he walks again towards the sensor, the distance will further decrease, right? At a constant rate of 0.5. Now again, the rate or speed is given to us as 0.5 for 2 seconds. And time is 2 seconds. So when you multiply, this distance is going to be, for 2 seconds, it is equals to distance in 10 will be, when you multiply you get 1. So he walks 1 more second here. So 8, 9 and 10. So at 8 he is there for 2 seconds at a speed of 0.5 meters per second. He further covers 1 meter. And towards means distance is closing. So therefore it is again like this. And there it is going to come, 10 seconds, right? So there it is. So we'll again draw this graph like this. So that becomes the motion. Is that clear to you? So that represents the motion. The final position here will be 1 to 3.5 seconds. So this final point will be at 10, 3.5. Perfect. So these are the final positions. So D at 10 will be 3.5, 1 less than 4.5. Is that clear to you? So that is how. 9. The height of stone after t seconds falling from the edge of a cliff is given by the function h of t equals to minus 4.9 t square plus 200, where h of t is measured in meters. What is the average rate of change in the height of the stone in the second second? Now what does this second mean? So first second is from 0 to 1. That means t1 is 1 to 2. 1 to t2 is 2. So that is the second, right? And part B is what is the instantaneous rate of change at 1 second? Okay. So let's find average rate of change in the second, right? So that means we are looking into the interval from 1 to 2. Equation is given to us, so we get this as minus 4.9 2 square plus 200 minus, let's put it in brackets, minus 4.9 1 square plus 200 divided by 2 minus 1. Correct. So that is your second. Perfect. Now 200 will cancel, and you can write this as minus 4.9, and here we get 4. Minus and minus becomes plus. We get plus 4.9, right? So that is what we get. So which is 3 times 4.9 divided by 1, of course, and that becomes your answer, right? So we can write this as 3 times 9 is, so basically 3 times 9 is 27, 7, 2, 3 times 4, 12, 14.7 meters per second. So that becomes the average rate of change in the second. Well, second part is what is the instantaneous rate of change at 1 second. So I didn't really leave much space here. Okay, so I'll use another ink and write down the instantaneous rate of change at t equals to 1, right? So which will be equals to minus 4.9. So we'll take t as 1.01 whole square, right, plus 200 minus 4.9 1 square plus 200 divided by 0.01. Correct. So let's calculate this. We know here 200 and 200 will cancel, and we could take this as, let me push the page a bit. We could write this as minus 4.9 over 0.01, and we have within brackets 1.01 square minus 1. Is it clear to you? Right. Okay. So that gives us, so that is 1.01 whole square. So we have 1.01 whole square minus 1 equals to, we are going to multiply this by 4.9 and divide it by 0.01. So in decimals, this number is negative 9.849. So that is our answer. It is so much meters per second. Is it clear to you? So that is how you will do it. So approximately 10 meters per second. Minus indicates that the object is falling, right? And therefore it is in the negative side rate of change. Here is an excellent question from previous test paper. Let us see how to solve such questions. Question number 10. Determine the value of a so that the average rate of change of the function g of x equals to x squared plus 2x minus 4 on this interval minus 2 to a is 5. So we are given average rate of change in this case, and we need to find when will that occur, right? So average rate of change in the given interval can be written as g of a minus g of minus 2 over a minus 2, correct? So substituting the values, we get here a squared plus 2a minus 4 minus, substituting minus 4 minus 2 here, we get 4 minus 4 minus 4, correct? Divided by a plus 2. And we are given this as 5. And we need to find a. Now since in this equation a is only variable, it's easy to find, right? So we'll multiply, cross multiply. 5 times a plus 2 is equal to, so let's open this bracket. So what you notice here is 4 minus 4 is 0. So when you open, they cancel away, right? And they also cancel away. So we're left with a squared plus 2a. Now we can solve for a. 5a plus 10 equals to a squared plus 2a. Bringing all the terms together, we get 0 equals to a squared plus 2a minus 5a plus 10. So that gives us 0 equals to a squared minus 3a plus 10, correct? So that is 5 times 2, so which is a minus 5 times a plus 2. Now since a is greater than minus 2, we can take A as 5, right? So from here, the valid answer is A equals to 5, correct? So our answer here is A equals to 5. So that is how this question can be solved. I hope the steps are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. Here is a thinking question on rate of change. The question here is, the population in thousands of a town is modeled by the function p of t equals to 2t squared minus 7t plus 5, where t is the number of years after 2000. When is the population of the town increasing at the rate of 5,000 per year? So in this particular case, we are given instantaneous rate of change, right? And we need to find the time when this happens. So we should use the method of difference quotient, right? So we'll use the method of difference quotient. So instantaneous rate of change is when we are talking about time which is slightly more than t, right? So we'll have that difference. So basically we'll find the difference between the population at that time, right, like this. And here we are assuming that this h is very, very less. So where h is very, very less as compared to 1, right? So when we say, when is the population of the town increasing at the rate of 5,000 per year, now the population is given in thousands. So if you link these two, so in this equation, we have to use the value 5, right? So we could write this as 5 equals to t plus h. So we get 2 times t plus h whole square minus 7 times t plus h plus 5 minus the whole equation 2t square minus 7t plus 5 over h. Correct? So that is what we need to solve for. So let's write down the expansion and then work it out. Well, you'll notice that this 5 and 5 will cancel. And when you expand, 7 times t will all, let's first expand, right? So we get 2 times t square plus 2th plus h square. That's what we get from the first term. And here we get minus 7t minus 7h minus, open this bracket, minus 2t square plus 7t, right? All this times 1 over h, correct? Okay. Now, 2 times t square cancels, right? And we are left with 2 times 2th. So let's see what terms we are left with. Two times 2th is 4th plus 2h square minus 7t and plus 7t cancel. And we are left with minus 7h over h, which is equal to, now h is common in all these terms, so we can write h common. So we got 4t plus 2h minus 7 over h. Now this h cancels, correct? We also know that h is very small, so we could actually write this as 4t minus 7. Since we know that h is very, very small as compared to 1, approaching 0, right? So this portion will be 0. So now we'll solve this equation. 5 equals to 4t minus 7. So bringing 7 to this side, we get 5 plus 7 equals to 4t, right? Which is 12. So 12 divided by 4 is equals to t. And that gives you that t equals to 3. So after 3 years, the rate of change will be 5,000 per year, right? So the answer here is, where is the population of the town increasing at the rate of 5,000 per year? So you started at 2,000, right? So it was earlier. 0 is at 2,000. So answer will be in 2003. That will be correct. Is that clear to you? So that is how we can actually solve such a question. I hope that makes sense. Now this is a prerequisite course for calculus. Here is an excellent question based on rate of change. The question here is, find the rate of change in the surface area S of an optimal cylinder topped up with a hemisphere when the radius is 4 centimeters. Assume the bottom of the cylinder is included in the surface area, but the top is covered by the hemisphere. Formulas which are related are given to us. Surface area of a regular cylinder is 2 pi r square plus pi r h, and surface area of a sphere is 4 pi r square. You can always pause the video, answer the question, and then look into my suggestions. Now let's sketch the scenario. So we have a cylinder, so we can say the cylinder is kind of like this. Now when we say optimal cylinder, it means what? And that is interesting. Optimum means that diameter is equals to height. So first thing which you should understand is what is optimal cylinder. That means diameter equals to height. So in our case, diameter is 8 units, right? Radius of 4 means diameter of 8, right? Radius of 4. So that means height will be 8. Is that part clear to you, right? So that is the very first thing which should be absolutely clear. Now it is topped by a hemisphere. So that means we have a hemisphere here on the top. So that is the hemisphere. So this surface area should not be counted as it is part of your hemisphere. Correct? It is inside. Okay, now let's write down the formula. We need to find the rate of change in surface area. So what is the surface area in this case? Surface area will be area of this cylinder, not including this but including the bottom. So in the formula, it will be pi r square, the circular area right there, plus lateral area pi r h, plus half of the sphere, right? So half of 4 pi r square. Is that clear? So that becomes your formula. So we have 2 pi r square and pi r square as 3 pi r square plus pi r h. Is that clear? So we get our formula. We combine these terms. It goes 2 times. So we have 2 pi r square and pi r square as 3 pi r square and pi r h. Perfect. So that is how we get our surface area. Now it says find the rate of change in surface area of this, right? Optimum cylinder. Optimum means we have taken height as diameter when the radius is 4 centimeters, right? So when r is equals to 4 centimeters. And clearly height will be 8. So these are the values given to us in centimeters. Correct? So now we'll find. So we'll have instantaneous rate of change of S as equal to. So in this particular formula, we'll use the value of R as 4 and we can write H as 8, correct? Which is twice R, which is twice R. So we have 3 times pi. We'll take the value 4 and 4.1. Okay, we'll keep it simple, 4 and 4.1. So first we'll take R as 4. You can write 0.1. We're just doing calculations with calculator, right? So plus pi R here will be 4.01 times height, which is twice this. right? So it is 8.02. So that is the surface area when it is 4.01. And from this, we'll take away minus 3 pi 4 square plus pi times 4 times 8. Is that clear? Divided by all this, divided by, we have taken 0.01, so 1 over 0.01, difference between these two. Is that clear to you? Correct? So that is how we are going to calculate it. So let me rewrite this. So what we get here is we can take pi common. So we'll calculate, we'll take pi common over 0.01, and within brackets we'll write 3 times 4.01 square, and here we have plus 4.01 times 8.02. And when you minus this, we have to minus both, right? So let me write small brackets here. Okay. We'll write minus 3 times 4 square, and we'll do minus 4 times 8. Correct? Let's use the calculator and find this. Okay. So we have 3 times 4. Let's use brackets. So we have 3 within brackets 4.01 square, bracket close, plus 4.01 times 8.02 minus 3 within brackets 4 square minus 4 times 8. Correct? So let's use the calculator to find this answer. We have 3 within brackets 4.01 square, bracket close, plus 4.01 times 8.02 minus 3 times 4 square is 16 minus 32. And this will be multiplied by pi times, let's say, 3.14, and we'll divide this by 0.01. So we get equal to 125.757. Right? So centimeters. So area, so we have area on the surface area, which will be centimeters square, over the radius, which is centimeter. Correct? So that becomes our instantaneous rate of change. Now that could be rounded to approximately, let's say, 126 centimeters square per centimeter. Correct? So that is how we are going to solve this question. So I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.